Hey scholars, welcome back. Today we're diving into complex numbers. This is something that you're probably going to see in high school. A lot of people get confused on this, probably because it is something that they've never seen before. Today we're going to figure it out, okay? So we start with the idea that the square root of a negative number does not exist. Why is that? Because there's no number that you would multiply by itself to get a negative number. Why? Because a negative times a negative is a positive, and a positive times a positive is a positive. So that's the problem here. I swear this will look good. So for that reason, mathematicians do as they always do, and they invent something that doesn't exist. Funny, right? This frustrates a lot of people, but I think it's kind of fun. I is used so that we can express this phenomenon. Because sometimes when you solve a quadratic equation, you end up with a negative in the square root. In a complex number, it looks like a plus bi, where the real part is going to be the a, and the complex part is going to be the b. So this is what a complex number looks like. 2 plus 3i. The real part is going to be the 2, and the imaginary part is going to be 3. As you can see here, this is the real number line. And the way we visualize this is using this y-axis as the imaginary axis. So the way that we are going to plot this point is we go over 2, up 3, and we get 2 plus 3i. Okay, let's add it. The way that we do this, we have a plus bi, that's one complex number, plus c plus di, another complex number. The way we do that is we add the real parts, and then we add the imaginary parts with that I on the outside, right? So let's do this one. The real parts are going to be 5 plus 9, plus the imaginary parts, which is going to be, we have to put the I on the outside, and then we do 7 minus 3. Okay, plus 4i. That's all. That's literally all. Okay. Sounds weird because we have to deal with this I, and then we have to deal with this negative 7 minus 3. So like lots of things to pay attention to, but it's as simple as that, right? So let's do this next one. We have one complex number and another complex number. So let's do the real parts first. 24 minus 3 plus I. Then we do c plus d, which is going to be, there's no c here, so it's just going to be 4. Okay, so we do 21 plus 4i, and that is our final answer. Okay, so that's adding complex numbers. Now we go to subtracting. Okay, so subtracting is a similar thing. We have one complex number and then another complex number. We subtract the real part, and then we subtract the imaginary part. Okay? And we're also paying attention to the signs of all of these A, B, C, and D's. So we have 24 minus 8, which is the real part. We do plus, of course, I, and then we do minus 5 minus 4. So we get minus 5 minus 4. That is going to be equal to 24 minus 8 is 16 minus 9i. Okay, so the correct way, by the way, the correct way to express a complex number is real part and then imaginary part. The real part and the real part here. So we have 2 minus 24 plus I, this I right here, what is in front of it? What is in front of it? We got a 1 in front of it, minus this minus 4, which is really plus 4. Because negative and negative equals a positive. The final answer, minus 22 plus 5i. And boom, that is adding and subtracting complex numbers. Thank you so much for watching. We're going to continue making videos. As always, leave requests. We also do online tutoring. If you're interested, check out our website. Bye.